Hey guys, today we're going to look at the last lesson in our packet, lesson 2.6, positions in the distribution. So we're going to look at locations and distribution. Below are the recent Intro to Stats quiz scores in percent form. So we've got all of our numbers listed here. So you want to take these numbers and you want to find our mean and our standard deviation. So if you want to grab your calculator, pause the video and find those numbers. Okay, our mean would be 76.4% and our standard deviation would be 12.49%. So we're going to use those numbers for our next two questions. Or I guess no, those numbers won't actually be used for next two questions, but they'll be used later on. So number 1 wants to know, Ron scored a 60 on the quiz. What percent of the scores are less than 60%? If we look at all those scores listed above, we would see that there are 3 scores less than 60. And there are 20 scores altogether. So that would give us 15% got less than 60. And then try that same thing for Hermione. Hermione scored a 90% on the quiz. What percent of the scores are less than 90%? Go ahead and pause this and try the problem. Okay, you should have seen that 18 people scored less than 90. So 18 out of that 20 is going to give us a 90%. So what do these percents mean? That means for this quiz, Ron was in the 15th percentile, and Hermione was in the 90th percentile. The 15th percentile because 15% scored less, and the 90th percentile because 90% scored less. So that's our vocab word here is percentile. A percentile is the percentage of data points that are less than a specified data point. So last class we talked about our quartiles, Q1, Q2, Q3. Those correspond to some of our percentiles. Because that Q1 means about a fourth of the data is less than Q1, so that makes it our 25th percentile. Q2, our median, about half of the data is less than that, so that makes it our 50th percentile. And Q3 would be our 75th percentile. So let's interpret our percentiles. The O-give represents the cumulative frequency distribution for the SAT test scores of a college-bound student in a recent year. What test score represents the 62nd percentile, and how would you interpret this? So we would look at our percentiles, our y-axis. 62 would be about here. So we come over and we go down. So the score would be about 1600. And then how would we interpret that? Remember, our percentile means that's the percent that got less. So 62nd percentile would mean 62% of people got less than a 1600. And then we come back to our quiz data. Remember, our mean was 76.4 and our standard deviation was 12.49. That's going to help us out here. Question 3 wants to know how far away from the mean Ron's score of 60% is. So we want to figure out how far away it is. So we do 76.4 minus Ron's score of 60. It is 16.4% away to the left or less. Okay. So how many standard deviations away is Ron's score? So we would take that 16.4 and we divide it by our standard deviation. That would give us 1.31. So Ron is 1.31 0.31 standard deviations to the left. Okay. And then we're going to look at Hermione's as well. So this one wants us to look at Hermione's score of 90. So we want to see their difference. So it would be a difference of 13.6% from the mean, and hers is to the right. And for how many standard deviations away, we take that 13.6 and we divide it by our standard deviation. Give us 1.09. So Hermione is 1.09 standard deviations to the right of the mean. So this, when we put it into this perspective of how many standard deviations away from the mean we are, we call it our standard score, our z-score. So the z-score represents the number of standard deviations a given x value falls from the mean, which is either mu or x bar. A negative z-score means the x is to the left or below the mean, and a positive z-score is to the right or above the mean. So we have two formulas for our z-score, and it really just depends on if it's a population or a sample. So our first one, our sample, would be x minus x bar over Sx. So it's your data point minus your mean divided by your standard deviation. So that's the same thing for our population, except this time just our little characters are a little bit different. X minus mu over sigma, but that's still your data point minus your mean divided by your standard deviation. So let's practice with that a little bit. In 2009, Heath Ledger won the Oscar for Best Supporting Actor at age 29 for his role in the movie Dark Knight. Penelope Cruz won the Oscar for Best Supporting Actress at age 34 for her role in Vicky Cristina Barcelona. The mean age of all Best Supporting Actor winners is 49.5, with a standard deviation of 13.8. The mean age of all Best Supporting Actress winners is 39.9, with a standard deviation of 14. Find the z-score that corresponds to the age of Ledger and Cruz and compare your results. So first, let's find our z-score for Ledger. We need our data point, our mean, and our standard deviation. So our data point would be 29. Our mean would be 49.5. And our standard deviation would be 13.8. If we plug that into our calculator, we should get negative 1.49. So Ledger is 1.49 standard deviations away from the mean, and it's to the left, or it's below the mean. Now let's do Cruz. It's that same formula. We need our data point, which is 34, minus our mean, which is 39.9, all divided by our standard deviation of 14. And we should get a z-score of negative 0.42. So that means that Cruz is 0.42 standard deviations away from the mean. It's still negative though, so it's still to the left, still below the mean. So if we compare those results, we can see that because Cruz's the absolute value of her score, 0.42, is much closer to the mean. The larger the z-score, the further away from the mean that you are. Okay, on our very last page, on that back part, it had a check for understanding. So go ahead, pause the video here, and try 1 through 3, and come back and get your answers. So number 1 wants to know at what percentile is North Dakota with a household income of 55,766. So we want to look at our OGIV chart. I want to go to about 55,000 up and over. It's going to be about 65, the 65th percentile or the 70th percentile. Okay, so it'll be about 70th percentile here. Okay. My things got in the wrong order, so we're going to skip and look at our answer for number 3. It wants the z-score for New Jersey. So it gives us our data point. And then the mean is up in the summary next to the OGIV chart, along with our standard deviation. So we plug those numbers in, and we get a standard deviation of 1.8. So interpreting that is New Jersey is 1.8 standard deviations to the right or above the mean. Okay, and finally, number 2, we're going to hop back to that. Estimate and interpret the first quartile of the distribution. So remember, quartile 1 is our 25th percentile. So if we go look at our OGIV chart and start at 25 for those percents and go over and down, we'd find that it's about $45,000. So interpreting that would be that 25% of states make less than $45,000 on average. Okay, if you guys have any questions, need to see anything again, make sure you stop into tutorials.